So hello everyone, today's concept is current electricity. Now this current electricity has three important concepts: voltage, current and resistance. So we will get into them with one by one. So the first concept is current. Now current is defined as rate of flow of charge per unit time. I equals to Q by T. Q stands for charge and T stands for time. The unit of SI unit of charge is coulomb and time is second. Now we have one more concept. One electron has 1.6 into 10 to the minus 19 coulomb of charge. So one charge will have 6.25 into 10 to the power 18 electron, as you can see here. Using unitary method we get into this. So one charge will be carried by 6.25 into 10 to the power 18 electron. So basically what happens, due to this flow of electron, a current will flow from positive to the negative terminal. So this we have the concept of current here. Now we'll move on to the concept of voltage. So what is voltage? So voltage is basically work done by a unit bringing a unit positive charge from infinity to a point. So its formula is work done by charge. So work done, SI unit of work done is joule and charge is coulomb. Now what happens if we have two bodies here? Suppose these two bodies are there. Now this has voltage V1, this has voltage V2. So the difference between these two voltage will be equals to W by Q. W, as I told earlier, work done in bringing a unit positive charge from infinity to that point. Now we will move on to the third term, which is resistance. What resistance does? So before going into resistance, let us get into one of the most important law of electricity, that is Ohm's law. So Ohm's law states that V will always be directly proportional to current. And two conditions we need to follow for this law, that is all physical quantities should be constant and the temperature should remain constant. So now V is directly proportional to I, V is equals to IR, or I is equals to R equals to V by I. So now what is the concept of resistance? So resistance is basically limit to the flow of current. So now after completing all these three things, current, voltage, resistance and Ohm law, in my next lecture I will tell you about the concept of resistivity and conductivity. Hello friends, so in our previous lecture we discussed about three important concepts: voltage, current, resistance and Ohm's law. So and Ohm's law was the fourth one. So now we will move on with resistance. Now this resistance depends on three important parameters. One is length of the material, second one is temperature, and third is the area of cross section. So now resistance is directly proportional to the length, inversely proportional to area of cross section. Now since we need to have a proportionality constant which is called rho. Now rho is known as resistivity of the material. So now we'll further move on. We have two more concepts here. Now ohmic conductors and non-ohmic conductors. What are these things? So these two things are, ohmic conductors are those material which obeys Ohm's law, and non-ohmic conductors are those material which does not obey Ohm's law. Now I will explain you this concept with a graph. So here we have a graph, voltage, current. So as you can see in the graph, voltage is on the y-axis, current is on the x-axis. Now as we know, voltage is directly proportional to current, so we are getting a straight line. So this is the concept of resistivity, and now further we will move on to find the unit of to find resistivity. Now how can resistivity be written in terms of resistance, length and area of cross section? So that can be done here. Rho is equals to R into area of cross section by length. Now the unit of resistivity, that is, the unit of resistance is ohm, area was meter square and length is meter. So as these two get cut, we have the unit of resistivity as ohm meter. So this was the concept of resistivity. From this concept, you will get many problems related to this chapter. So now, basically, in these two lectures, I have summed up the whole concept of current electricity. That was from current, voltage, resistance, Ohm's law, resistivity, and ohmic conductors and non-ohmic conductors. Now, one more concept, the last concept is left. That is of superconductors. Superconductors. Superconductors are basically material which have almost zero resistivity at very low temperatures. So this is all about superconductor. It's a very small concept. So by this I am summing up this chapter, including all those concepts. In my next lecture, we'll discuss some problems related to all these formulas. Thank you. Good morning, friends. Today we'll discuss the problems based on current electricity. So now you can see the question on your screen. So the question is, the filament of a bulb takes a current of 0.1 ampere. So here is the keyword. Now you need to note down some keywords here. So the first keyword is the current is 0.1 ampere when potential difference across it is 0.2 volt. So the potential difference across the bulb is 0.2 volt. So these two data are given. Now the other part of the question, when the potential difference across it becomes 1.0 volt, so this is the another keyword, the current becomes 0.4 ampere. Now you need to calculate the resistance of the filament in both the cases. So now we will move on to the solution. So for the first case, resistance is V1 by I1. That is 0.2 volt by 0.1 ampere. So by this we will get calculation. So that is 2 ohms. For the second case, R2 is equals to V2 by I2. V2 is equals to 1. Current is 0.4 ampere. So just move 10 by 4. That is equals to 2.5. So these two are the resistance in both the cases. In a conductor, 6.25 into 10 to the power 13 electrons are flowing from point A to point B in 2 seconds. Now we need to find the amount of electron flowing and the direction of current. So our given data or the keywords in the problem are 6.25 into 10 to the power 13 electrons, and the second point is it's moving from A to B and time given is 2 seconds. So the given data are number of electrons 6.25 into 10 to the power 13 and time 2 seconds, point A to point B. So now we'll move on into the solution. Now we all know one charge is carried by 6.25 into 10 to the power 18 electron, right? What we'll do here, we'll need to find 1 electrons. How many charge will be there for 1 electron? So that will be 1 by 6.25 into 10 to the power 18. Now what amount of charge will be there for this many electrons? So that will be 1 by 6.25 into 10 to the power 18 into 6.25 into 10 to the power 30. From here these two get cancelled and we get 1 by 10 to the power 5 coulomb of charge. So here we got the charge. Now we need to find the current. Now the formula of current, as we all know, is I equals to charge by time. Time here we know is 2 seconds. Charge is 1 by 10 to the power 5 coulomb divided by 2. So this will be basically 1 by 2 into 10 to the power 5. 1 by 2 can be written as 0.5 and this can be written as 10 to the power minus 5. So we can also write this as 5 into 10 to the power minus 6 or 5 microampere. As we know the relation, 1 ampere is equals to 10 to the power minus 6 microampere. Sorry. 1 microampere is equals to 10 to the power minus 6 ampere. So this was the relation. So this is the sum. I'll repeat it once again. First, we are telling that one charge can be taken by this many electrons, 6.25 into 10 to the power 18. So one electron will have 1 by 6.25 into 10 to the power 18 charge. Now 6.25 into 10 to the power 13 electron will have 1 by 6.25 into 10 to the power 18 into 6.25 into 10 to the power 13. These two get cancelled. So we got 1 by 10 to the power 5 coulomb. Now we know current is charge by time. This was charge, time was given 2 seconds. So we did some calculation, and since we know the relation 1 microampere equals to 10 to the power minus 6 ampere, we got the answer as 5 microampere. Now one more thing was there in the question. What will be the direction of the current? So as we all know, the direction of the electron was A to B. So direction of current is always opposite to the direction of electron. That will be B to A. So final answer is 5 microampere and current direction is B to A. Thank you. So coming on to the next problem, we have find the potential difference required to pass a current of 0.5 ampere in a wire of 80 ohm resistance. So here we have two key points in the question. One is the current, that is 0.5 ampere. Second is the resistance of the wire, which is 80 ohm. So we have resistance of wire 80 ohm, and secondly we have current, that is 0.5 ampere. So they have told to find the potential difference. Now we know the formula, V is equals to IR, which is 0.5 into 80. That will be equals to 5 by 10 into 80. 5 to the 10, 2 4 side. So we got the voltage as 4 volt. The resistance was 80 ohm. Current was 0.5 ampere. V is equals to IR, 0.5 into 80, and we got 4 volt. So this is the answer. Thank you. So moving on to the next problem, we have an experimental data based on Ohm's law. So I'll write the values V, I, 0.5, 1.5, 2.5, 3.5, 4.5. V stands for volts and I for current. The values are 0.4, 0.6, 0.8, 1.0 and 1.2. So we'll plot a graph for the given data. Current, voltage. Now the values are 0.4 for current, 0.6, 0.8, 1.0 and 1.2. For voltage the values are 0.5, 1.5, 2.5, 3.5 and 4.5. So first let us draw the points. Okay. Now our first question is current when voltage is 2 volt. So voltage will be 2 volt here between 1.5 and 2.5. Just take a straight line. and this point will be the current, that is between 0.6 and 0.8. I'll write the answer here. So for our first question, the current is 0.7 ampere when the voltage is 2.5 volt. 2 volt. Now moving on, voltage when current is 0.9 ampere. Now current will be 0.9 ampere between 0.8 and 1.0. So we are moving here, we are coming here. This is 3 volt between 2.5 and 3.5. So our answer is V is equals to 3 volt when current is 0.9 ampere. These two were the questions. Now the third question, resistance of the total circuit. So here we don't need to do anything, just take R is equals to V by L. Now you can take any value out of these. Let us take 0.5 by 4 by 0.4. 0.5 volt, 0.4 ampere. That will be 5 by 10 into 10 by 4. We got the resistance as 1.25 ohms. I forgot this. Yeah. So the third answer is resistance equals to 1.25 ohms. So this was the 3 questions asked. Thank you. Hello friends, so today we will discuss some more concepts in current electricity. So what are those concepts? EMF, terminal voltage, internal resistance, series combination and parallel combination. So we will go into these one by one. First let us come into EMF. For EMF, let us take a vessel with an electrolyte inside it. Okay. Now electrolyte you have studied in your chemistry. So and we have two metals, metal 1, metal 2. Now what is happening in electrolyte, due to some chemical reactions, ions get originated. Now these ions will either attract metal 1 or attract metal 2 depending upon their electron configuration, if they want some electron or they donate some electron. Due to this exchange of electron or flow of electron, basically a terminal voltage will be created. Now this terminal voltage is known as EMF. So what EMF constitutes? The entire current, that is when there is no current basically inside the vessel, when there is no current drawn from the vessel, then the voltage is known as EMF. So this is what EMF is all about. Second, we will move on to the concept of terminal voltage. I will get into the formulas later. So first, here what terminal voltage constitutes is the current that is flowing outside this cell. In EMF, we were having the current that was inside the cell, but here the current that is outside the cell will only be taken. So the voltage that will be developed due to the current outside the cell is known as the terminal voltage. So this is the difference between EMF and terminal voltage. In EMF no current is drawn, in terminal voltage a current is drawn here. So that will be the difference. Now let us come into the definition of voltage. What we studied in our last video, that was the amount of work done in bringing a unit positive charge from infinity to a point. So what is happening? In EMF we are moving a unit positive charge around the entire vessel, and the amount of work done in doing so is the EMF. Again I am repeating this point, EMF includes the entire cell, inside and outside, no current is drawn from the cell. Please remember this. Second is terminal voltage. In terminal voltage, we are just considering the part that is outside the cell. We are not considering the part that is inside the cell. So we will have a different work done as compared to this work done. That's why I have given W dash. Okay. So this is V equals to W dash by Q. Now what is happening? You see here. In EMF, we were taking the entire cell. That was the outside voltage, the inside voltage. But in terminal voltage, we are just considering the outside voltage. So there will be a voltage drop. Now this voltage drop V will be equal to EMF minus the terminal voltage. Okay. Now since we have a voltage drop here, we will also have some internal resistance here, because anywhere where there is a voltage, a current is flowing, there will be some resistance to the flow of current. So what is that? So here we write V is equals to I and small r. Small r represents the resistance that is inside the electrolyte cell. Okay. So now we can write R is equals to V by I. Okay. So R is equals to, this V can be written as E minus V, and I. Now I can be taken as we know from Ohm's law, V by R. This was V by R. So we get here E by V minus 1 into R. This is the expression for internal resistance of the battery. Alright. So this is the concept of EMF, terminal voltage and internal resistance. We have some more derivations here. We can manipulate these relations. So let us take one example. How can we manipulate these relations? And you can just pause the video and copy all this for a moment. So I hope you have copied all these. So now we'll get into some other relation. That is, the resistance is equals to entire voltage inside the cell, that is E, and the total resistance that we have, that is the resistance R. Sorry, I was concentrating on I just did something mistake, so don't get into that. The current is equals to voltage by resistance, we all know by Ohm's law. The total voltage inside the cell is E, and the total resistance is the resistance plus the internal resistance, that is due to this battery. So now what we will do, we will write an expression for EMF, that is equals to I into R plus R. So all these relations will be helpful for you when you are solving some problems related to all these concepts. Okay. So this is done here. Now we'll move on to the next two concepts, that are the other two concepts are series combination and parallel combination. For this I think I need to remove all this. So series combination and parallel combination. So before, we have two theoretical concepts here. We do series combination to increase our resistance of that circuit, of that particular circuit, and we do parallel combination to decrease that resistance of that respective circuit. So we have here, let us have a circuit here. We have a circuit R1, R2, R3. We have three different resistors. We have a current I flowing in this circuit, and this is the voltage, terminal voltage. Okay. So now what we'll do, we know that we'll have same current flowing across all these resistors. Through all these resistors, the same current will flow. But we'll have different potential difference across each resistor. Okay, that is V3, V2 and V1. What we'll do here, by Ohm's law we know V is equals to IR. Okay, now, so V is equals to V1 plus V2 plus V3. That only constitutes the entire voltage, right? This voltage plus this voltage plus this voltage. This constitutes the entire voltage V. What I will do here, I write I into R1 plus I into R2 plus I into R3. Since the total current flowing through each resistor is I, the same current that has been originated from this point. This is the positive terminal, this is the negative terminal. Okay. I take I common here, we'll get R1 plus R2 plus R3. Okay. So and this total is equals to IR from this equation. Okay, this equation 1. Now we can cancel out II. What we get? R is equals to R1 plus R2 plus R3. So this is what we call series combination of resistance. In order to increase the resistance of a circuit, we use this combination. Okay. Now we'll move on to the parallel combination. What is that? Let us see. As I told earlier, parallel combination is used to decrease the resistance of the entire circuit. So for that, again we'll have a derivation here. When I'm going at circuit is easier for you. Suppose we have a resistance here, we have a resistance here, and we have another resistance here. We have a battery source here. Okay. Here what happens? See carefully. We have a different current. We have a current I here. We have a different current I1 here, a different current I2 here, and another different current I3 here. Okay. We had this current I that has been divided into three parts: I1, I2, I3. Since these are the three branches of resistance we have in the circuit. This is R3, this is R2, this is R1. Okay. Now what we do? Here, since the combination is in parallel, it will have same voltage. You can see same voltage across all the resistance. We are having same voltage since the combination is in parallel. Okay. So now we'll take I is equals to V by R. We know by Ohm's law. So V by R is equals to, again I am taking from the previous step, sorry. V is equals to V1 plus V2, this is missing here. I is equals to I1 plus I2 plus I3. Okay. So this is the first equation. From here we will derive this, the parallel combination. Okay. First we will take V by R. Okay. Now since we know in every terminal we have this V same. Across each resistance we can see the voltage is same. Alright, what we will do? V by R. By Ohm's law we know that R1 is the resistance, voltage is same. Second we will take V by R2. Third one V by R3. Again we will take V common. Okay. We take V common, we get 1 by R1 plus 1 by R2 plus 1 by R3. V will get cancelled off. We will get this 1 by R1 plus 1 by R2 plus 1 by R3. I am writing the equation here since we don't have space here. So basically this equation is 1 by R is equals to 1 by R1 plus 1 by R2 plus 1 by R3. So this combination is known as the parallel combination. Why we use this combination? Since we need to reduce the resistance in a particular circuit. So now I just want to tell you one more concept for parallel combination, that is 1 by R. We derived this equation in our previous video. So 1 by R2. This will go on to N. So now what is N? The number of resistors will have in that circuit, that is N. Okay. Now this was the concept of parallel resistance. Now suppose we have only two resistors, right? 1 by R is equals to 1 by R1 plus 1 by R. How we solve this? We take LCM R1 into R2 by R2 plus R1. Now this is the value for 1 by R. Now what will be the value for R? R is equals to R1 into R2 by R2 plus R1. So when we need to find the formula for just two resistors in a circuit, we can use directly this formula. So that is time efficient. Okay, now this is done. Now we'll move on to numericals. question will be displayed on your screen. I'm just reading it out. Calculate the equivalent resistance between A and B. Figure is given in your screen. Let us draw the figure first. So they have told us to calculate a resistance between two terminals. Okay. So this is what the given figure we have. Now the values are 3 ohms, 2 ohms, 6 ohms, 4 ohms, 5 ohms. Okay. Now how we'll move on this. Here we have been told to calculate resistance between these two terminals A and B. Now what we have here, we have a resistance here, we have a resistance here. Now what can you comment on this? Whether these two resistors are in series or are in parallel. So since we can see if the current starts to flow here, the same current is going in this resistor also. So what we can see or what we can conclude from this, these two resistors 3 and 2 are in series. So let us open this circuit. If we open, we write these two resistors as 3 ohms and 2 ohms. Okay. Now we have this resistance 5 ohm. As you can see, if the current is flowing in this circuit, we will have a different current for this resistor, the same current for these two resistors, and the same current for these two resistors. So now what we can comment here? We have a 5 ohm resistor here, and we have these two resistors. Since they are in series, if we open the circuit, we can write this as 6 and 4 ohms. This is 5 ohms. So now I think the diagram is much more easier for you. We have don't ever forget to write the units. Okay. So we have 3 resistors. We have 6 resistors in total. 2 are in series. One is in parallel with this, and it is also parallel with these two. So now we can calculate it very easily. What we'll get here? Suppose this equivalent resistance is R1. We get this as 5 ohm. This one is 5. We know that, given in our question. Second one, the third one, that is R3, 10 ohms. Now we calculated the equivalent resistance of this branch. This branch it's already known, and this branch we also calculated. Now these 3 branches are in parallel. So what we'll do here, 1 by 5 plus 1 by 5 plus 1 by 10. That is only the formula for calculating the parallel resistance. Okay. So we take LCM 10. We get here 2 plus 2 plus 1. That is 5 by 10. That is the value of 1 by Rp. Okay. So 1 by Rp value is 5 by 10. We need to calculate the value of Rp. That will be 10 by 5. And our answer will be 2 ohms. Okay. So you got all this. What happened here? I am just repeating. We have 3 terminals. One has 2 resistance, 3 ohm and 2 ohm. One has only one resistance, 5 ohm, and one has another 2 resistance, 6 ohm and 4. We just opened all the 3 branches of this circuit. First was 3 ohm resistance. Second was 2 ohm resistance. In the second branch we had only one resistance, 5 ohm. In the third branch we had 6 ohm resistance and 4 ohm resistance. What we did? We calculated the series combination. R1 equals to 5 ohm, 3 plus 2, and R3 is equals to 10 ohm, 6 plus 4. The 5 ohm was already given here. Now we calculated the parallel combination of these 3 series combinations. We got 5 by 10 by this calculation, and this is 10 by 5, which is 2. So the equivalent resistance of this entire circuit is 2. Okay. So we'll move on to the next problem. So the question is calculate the five resistors of 3 ohms are connected as shown. So let me draw the figure first. We have 5 resistance connected in this form. Okay, and the values of each resistor is 3 ohm. Okay, so in the question it is told that we need to calculate the resistance between 2 points P and Q, A and B. First we will calculate the resistance between P and Q. Okay, now again you can see here, if we take the current started to flow from here, we are getting at this point 2 branches. One branch is going this side, other branch is going this side. What you can conclude from these two things? First thing, this current is same as this current, right? Because we don't have any diversion between these 2 points, right? So the same current is flowing in both these resistors. We got the first concept. Second concept is we have this second line that is going into this resistance. This current is flowing into this resistance, this current is flowing into this resistance. So basically these two resistance are in series and this whole combination is in parallel with this resistance. Okay, so we will again redraw this circuit so that it looks simpler. So we have these two resistance, R is equals to 3 plus 3, that is equals to 6 ohms. Okay, since these two resistance are in series. Now this entire combination is in parallel to this 3. What we'll do here, 1 by Rp is equals to 1 by 6, the entire value of these two resistance, plus 1 by 3. Here we'll get it as, what we can do here, I told you about one formula, right? Rp is equals to R1 into R2 by R1 plus R2. I told when we have only two resistance in parallel combination, we can use this formula. So what I'll do here, this is R1, this is R2. 6 into 3 by 6 plus 3. What we get? 18 by 9. Answer is 2. We got the value of this entire combination, that is 2 volt. Okay, so I write RAB is equals to, sorry, RPQ is equals to 2 ohms. Okay, now the second part of the question, that is to find the resistance between A and B. What we'll do here, so we'll redraw the circuit, that is A, B, this is 3 ohm, this is 3 ohm, and the total combination of this resistance we are getting RPQ as 2 ohms. Okay, so now what we see, if we allow the current to pass through this branch, the same current will go into this resistance, the same current will go into this resistance. Therefore, these three resistance are in series. So what we will do, RAB is equals to 3 plus 2 plus 3, which is equals to 8 ohms, which is our answer. So in this sum, we were required to find two resistance. One was the resistance between P and Q. Second was the resistance between A and B. First what we did, we just opened this circuit. So we got these two resistance here and this resistance is parallel to these two resistance. After that, since these two resistance were in series, we added them. We got 6 ohm. This was in parallel, that was 3 ohm. Now by our formula which I told you, we can do, since we need to find the RPQ, that is the parallel equivalent resistance of these two, we can use this formula. We got 2. From here, we again redraw this circuit. We know this equivalent resistance, which is 2 ohm. Now, as the current will pass through this, in all the 3 resistors will have the same current, therefore they are in series. We'll just add these 3 resistors value. What will get? 8. This was our answer.